Alright, so part 2 of the video. I'm going to do 2 or 3 more examples for you. The first one is I'm going to set up a conjunction. We'll say, call this, I don't know, example 1. And it's -2 is less than m plus 4 is less than or equal to, let's make that m plus 1 is less than or equal to 4. Alright, so -2 is less than m plus 1 is less than or equal to 4. This is a conjunction because you can see it's combined 2 different inequalities. And you can actually solve it similar to solving an equation or solving something that we did yesterday or today in class. But instead of there being 2 sides to this inequality, there's actually 3. So when we subtract 1 to get the variable by itself, we have to do that to all 3 sides, which I don't think has happened to us before. So now we have -2 minus 1 is -3. The m is now all by itself, and 4 minus 1 is +3. And now when we graph that, the boundaries are at -3 and +3. And m has to be greater than -3, and so it's greater than, and also less than or equal to 3. So that's a filled-in circle, and it's less than. Now I don't go past -3 to the left or past 3 to the right because remember this is an AND statement, is a conjunction, and also known as an intersection, okay, which means only the intersection of the 2 separate graphs, so everything that works for both situations. Notice -4 would not work for the left side, and 5 would not work for the right side, so it's only those answers. Let's throw up a different example. Let's do 1 plus 5y is less than -4. Or, remember that word, I'm going to underline it, or. When you have a combined inequality, like the one above, this is like an AND statement. Okay, but the one we're working on now is an OR statement, and 4y, or 4y is greater than y plus 9. Unlike the AND statement above, you have to solve these separately. So we're going to isolate the y in each equation or each inequality. So the first one I'm going to subtract 1 from both sides. It's going to give me 5y is less than -5. Now I'm going to divide both sides by 5 and get y is less than -1. So that one's done. And or, I'll just write or for both of those. Let's get the y on the same side, so I'm going to subtract y from both sides. Now I'm going to divide both sides by 3. Since I didn't do any multiplication or division with a negative number, I don't have to flip any of the signs, so I'm okay. I'm going to set up the graph now. So I have boundaries at -1. I have a boundary at 3. So y is less than -1 looks like this. And y is greater than 3 looks like this. Notice there is no intersection whatsoever, but that's okay because it is an OR statement. Either one of these can be true, and the statement will be true. So for instance, if we choose -4, that makes this left statement true. If we choose +4, it would make this right statement true. The only things that don't work are this empty space in the middle here. So things like 0 would not be true for either one of these statements, so those are not included in the solution set. Or 2, the number 2 would not work for either of these statements, so we're not putting it in the solution set. So everything blue works. All right, that is the OR statement. So that should be enough for you guys to do any of the problems. Keep in mind, as you're solving these inequalities, if you divide or multiply by a negative number, you must switch the sign. So, for instance, I guess I could do one more. If your problem looked like this, negative 8 is less than negative 4p is less than 4. Let's do that one. To isolate that variable, we're going to have to divide everything by negative 4. Okay. When you do that, you'll get a 2, you'll get a p, and you'll get a negative 1. Obviously, you can't do that because negative 1 is not greater than 2, so that doesn't work. Because we divided by negative 4, the sign of the inequality symbols must change direction, and that makes sense. And you could actually rewrite it if you wanted, because a negative 1 is less than 2. A lot of people might want to rewrite that to look like this. Okay, notice they both say the same things, except the negative 1 is now on the proper side. That is an AND statement. It doesn't say AND, but whenever it's combined like this, it is an AND statement. So when you graph this, you graph the intersection of the two. So all you do is put the boundaries. The high boundary is 2. The low boundary is negative 1. It's got to be greater than negative 1, less than negative 2. Everything in between would be the answer. So keep that in mind when you're doing your calculations if you're dividing or multiplying by a negative number. For your homework, I'm going to assign 2 problems. Those problems are number 5, and that is negative 2 is less than a plus 1 is less than 3. Remember, that is an AND statement. That's a conjunction. I also want you to do 14. That looks like h plus 5 is less than or equal to negative 2. Or h plus 5 is greater than or equal to 2. Yep, that's correct. So notice the second one is an OR statement. So it's a disjunction, so you would graph everything, not just the intersection. All right, enjoy.